Today, we would like to present you the Wooden Catapult 2.0. This is a product constructed in collaboration between Design Tech class and AP Physics 1 class. In this experiment, we would like to investigate whether the lever arm directly affects the distance traveled by the projectile launched from the catapult.
By doing so, we have moved the projectile along a lever with changes in distance to the fulcrum. With 3 lever lengths each with 3 trials,
we gathered enough information to conclude the relationship as described above.
We measured and cut wooden boards and sticks to create the frame of the trebuchet, drilling extra holes in the lever arm in order to adjust its length and the position of the fulcrum. We secured a block of wood at the top of the frame to ensure that the arm would hit that block and release the ball at the same angle for every trial.
For the surgical tubing, F equals negative kx, which is the spring constants times the distance it was stretched, and work equals 1/2 kx squared, which is also 1/2 mv squared for the ball when the ball is released and all the energy is transferred into the ball. So if the ball is released at a consistent angle of 45 degrees, then its vertical and horizontal components should remain the same in terms of their ratio. And at 45 degrees, we have a maximum velocity, which will also result in a maximum range, or vertical distance, when it is released. So according to this formula, the larger the tension in the surgical tubing, supposedly, the farther the ball will go. Except our concern is that the height of the lever arm's release would be different in different cases, and that is what we wanted to test out.
The lever length of 1.3 meter was able to cover a distance of 11.88 meters. Unfortunately, we were unable to finish all 3 trials due to an unpredicted incident, where the force exerted by the tension exceeds the static friction force that was held together by the nails and the woods, and the whole launching pad got pulled down like this. However, we can still conclude that the distance traveled might be directly relating to the lever length with the torque formula, where a greater radius will result in a greater torque. With a greater torque, there will be more energy transferred into the ball when it is released, which eventually results in a greater range of projection.
The angle of firing wasn't too accurate because the wooden block stopping the lever arm was not secured enough and moved throughout the process. So the block had to be readjusted after each shot, which makes the angle inconsistent. Also, we were not able to use markers to mark the exact landing location of the projectile, and had to use eyeball estimates, which could become a possible source of error in the experiment itself.
This device may seem like a toy to most people. However, if we were to improve from the mistake we learned from this invention, the device can be used in many construction sites. Construction workers can calculate the distance of travel they want by using the formulas mentioned above, and use according lever lengths to move objects efficiently from one place to the other. Time and human power will be both saved.